A hurricane is a massive storm system. In fact, it's the most powerful type of storm on Earth. Hurricanes form over warm tropical waters and frequently move toward land. Before I forget to mention this, hurricanes are also called typhoons or cyclones. It depends on where exactly they form. Not all hurricanes are alike. Some are, more powerful than others. Meteorologists have a rating system for them. They use the term category to rank every hurricane that forms. The scale ranks hurricanes according to their wind speed and ability to cause damage. A Category 1 hurricane is the weakest. A Category 5 hurricane is the most powerful. A hurricane typically begins as a tropical storm. It has wind speeds between 50 to 100 kilometers per hour. When the wind blows faster than 100 kilometers per hour, the tropical storm has become a hurricane. A Category 1 hurricane's winds are between 100 to 130 kilometers per hour. A Category 2 hurricane has winds up to 160 kilometers per hour. Winds between 160 and 185 kilometers per hour indicate a Category 3 hurricane. A Category 4 hurricane has wind speeds up to 220 kilometers per hour. Anything above that is a Class 5 hurricane. Thankfully, those are quite rare. They are simply devastating when they form and make landfall. Oh, by the way, before you ask, typhoons and cyclones use different measuring systems. So what I just described only applies to hurricanes.
Okay, today's our first class, so I'd like to begin with some important definitions. We're going to use these terms all semester, so pay close attention. To begin with, chemistry is basically the study of matter. Matter is everything that makes up the universe. In this class, we're going to study the various elements and how they interact with one another. Sometimes they unite. When two or more elements unite, we call them compounds. Now, the study of chemical compounds is divided into two main branches of chemistry: organic chemistry and inorganic chemistry. Organic chemistry is the study of compounds that contain the element carbon. This basically covers, it covers all living things. Carbon is an element all living organisms have in common. As for inorganic chemistry, it's the study of non-carbon-based compounds. There are 5 differences between organic and inorganic compounds. Listen carefully to these. First, there are more than 10 million carbon compounds. That's 10 times the number of inorganic compounds.
Why are there so many carbon compounds?
Mostly because carbon bonds easily with other elements. It can also form complex groups. Got it? Okay, second, organic compounds melt and boil at lower temperatures than inorganic compounds. Third, organic compounds don't dissolve in water as easily as inorganic compounds. Fourth, organic compounds catch fire more easily than inorganic compounds. However, inorganic compounds conduct heat and electricity more easily. Finally, organic compound reactions take place at slower rates than do inorganic compound reactions. This winter has been rather cold. It almost feels like we're entering a new ice age. Now, don't laugh. This statement isn't as crazy as it seems. Yes, global warming is a hot topic these days, but more and more scientists are considering the possibility of global cooling occurring soon. This would result in the average temperatures on Earth dropping. It has happened in the past, and it will happen again in the future. Earth is warm now, but that's not always the case. In the past, large parts of the planet were covered in ice. We call these periods ice ages. Note the plural. There wasn't just one ice age. There have been several. During the recent past, we experienced the Little Ice Age, It lasted almost 500 years from around, say 1300 to 1800. The ice pack in the Arctic Ocean grew larger and moved south. Glaciers in the European Alps and on Greenland grew bigger and advanced southward. Temperatures dropped all over the northern hemisphere. Winters were longer, summers were shorter, and summer rains were heavier. There were numerous famines, since the cold and rain frequently destroyed crops. Why did this ice age and others like it happen? One theory claims that Earth's orbit caused them. Earth's orbit changes slightly over time, so the northern hemisphere receives less sunlight on those occasions. This reduces temperatures. It's possible that an orbital change caused the major ice ages. In case you're curious, the last such ice age happened around 20,000 years ago.
How often does Earth's orbit change?
No one knows for sure. Scientists estimate it changes between every 20,000 to 50,000 years. There's also a second possible reason for global cooling. This relates to decreased solar activity. The appearance or lack of sunspots can affect temperatures here on Earth. During the Little Ice Age, there were significantly fewer sunspots. For instance, in one 30-year period, astronomers spotted a few dozen sunspots. Normally, they would have seen tens of thousands of them. With less solar activity, some believe temperatures on Earth decreased, thereby resulting in colder weather. It's common sense that some objects are harder than others. We refer to this characteristic as hardness. But what exactly is hardness? Let me tell you. It's the ability of a material to resist being damaged, scratched, or marred in any way. There's even a way to measure it. It's the Mohs scale of hardness. A German scientist, a mineralogist named Friedrich Mohs came up with the scale in 1812. Here's how he made it. Mohs took 10 different minerals. Then he rated them from 1 to 10 based on their ability to withstand damage and to damage other materials. Talc received a rating of 1. It's soft, it's easily scratched, and can hardly damage anything. Diamond received a rating of 10. It's the hardest natural substance known to man. The other objects on the scale that number from 2 to 9 are gypsum, calcite, fluorite, apatite, feldspar, quartz, topaz, and corundum. I see worried looks on your faces. Don't worry about writing them down. They're listed on page 234 of your text. Take a look. Now, what about the hardness of other objects? It depends on which of the 10 minerals can scratch them. For instance, your fingernails get a rating of 2.5 on the Mohs scale. So talc and gypsum can't scratch them, but calcite can. What are some others? Let's see. Iron is rated between 4 and 5. Glass is between 6 and 7. And steel is close to 8.
Did any of you notice those strange greenish-colored lights in the sky last night? Anybody? Mark?
I did, sir. They were beautiful. But, what were they?
We call them the northern lights, but they're also called auroras. There are 2 types of auroras, those in the northern hemisphere and those in the southern hemisphere. In the north, we call them the aurora borealis. In the south, they're the aurora australis. Auroras appear as colorful streams of light in the sky in high northern and southern latitudes. They frequently occur during the months before or after the equinox. The equinox happens in March and September. That's when the planet is tilted so that it's neither pointed away from nor toward the sun. So, why do auroras occur? They're the result of a reaction in the upper atmosphere. Solar winds hit the Earth's magnetic field. This may excite the oxygen and nitrogen atoms in the atmosphere. After some time, the atoms become relaxed. As they relax, the electrons in these atoms give off energy. This energy appears in the form of light. The color of the light depends on whether it comes from oxygen or nitrogen. In addition, the height in the atmosphere helps determine the colors that the light forms. Also, just so you know, oxygen usually emits a green or brownish red light. Nitrogen typically gives off a red or blue light. Most auroras are green in color. For years, TV advertisements and print advertisements dominated the advertising industry. Yes, TV commercials and newspaper and magazine ads were expensive, but for most advertisers, the money they spent was worth it. People were watching television and reading newspapers and magazines. But times are changing. Television is still the biggest segment for advertisers, but that won't last for much longer. Instead, the Internet will overtake both TV and print marketing very soon. There are several reasons for this. First is the Internet's growing popularity. Today, the number of people who surf the Internet is enormous. In the 1980s, few people owned personal computers. Nowadays, most households have at least one PC. And more people are using the World Wide Web every year. People are also getting their news from the Internet. That's making print newspapers and magazines less popular. People are even watching TV programs on the Internet. So, as you can see, there's a growing audience available to Internet advertisers. Another important reason is cost. Making and airing a television commercial can cost a huge amount of money. For local TV, it might be thousands of dollars, but for national TV, it can cost hundreds of thousands of dollars. In some cases, advertisers spend millions of dollars to run 30-second commercials on highly rated TV shows or sports broadcasts. But it's much less expensive to advertise on the Internet. Internet advertisements are typically cheap to make. Many times, they merely provide a link to a company's website, and they don't cost that much either. Some Internet advertisements cost a few $100s or even less to place on another website. The most expensive ads rarely require more than several $1,000s. Finally, companies can advertise to specific groups on the Internet. All sorts of people watch TV or read newspapers and magazines. So an advertisement for baby products might not appeal to most of the audience or readers. However, a company advertising baby products on the Internet can buy ad space on websites that parents with babies often visit. This lets the advertiser get more value from its money.
You've all probably heard about zoning laws, but many people are confused about what they are. So I'd like to cover them now. Local governments such as cities and counties typically pass zoning laws. They regulate how people use the land in certain parts of the city or country. Think about our city for a moment. It's divided into various districts. Some are commercial while others are residential. This isn't accidental. It's intentional. The city developed this way because of zoning laws. You see, in the commercial district, there are businesses, and in the residential district, there are houses and apartments. You can't open a factory in the residential district, and you can't erect an apartment building in the commercial district. You can't do these things because of zoning laws. There are actually quite a number of zones. As I just stated, there are residential and commercial zones. There are also industrial, agricultural, and recreational zones. Industrial zones are for factories and other manufacturers. Agricultural zones are for farms, and recreational zones are for parks, lakes, and sporting facilities. So why do we need these zones? Well, think of it like this. Would you like a factory located right next to your house? How about a huge farm next to the shopping mall downtown? Or what about a big warehouse with lots of trucks next to the park? Yeah, that's what I thought. And that's why we have zoning laws. They keep various buildings or businesses out of places where they don't belong. The Mayans were a group of people who lived in Central America. They developed an advanced civilization. It lasted for it lasted for many centuries. Its high point was between the years 200 and 900. The Mayans are famous for a number of things. They built many city-states. These were like small countries. Naturally, the center of each was a city. Farms surrounded these cities and supported them with food. Mayan cities also contained exceptional works of architecture. The ruins of some buildings can be seen today. There are both large palaces and stepped pyramids. The Mayans had a writing system and literature, but they didn't use paper. Odd, no? Instead, they wrote on stone, wood, and tree bark. Lots of writing was done on the insides and outsides of their temples and palaces. They also formed books from tree bark, but sadly, few of these books have survived to the present day.
What happened to them?
Well, first, the heat and wet weather of the jungle destroyed many, but Spanish conquerors got most of them. They actively sought to destroy the Mayans' written records. Fortunately, other objects, including Mayan works of art, have survived. We can see some of this art on the stones of their temples and palaces. The Mayans were excellent pottery makers as well. They created figures of stone, clay, and wood, and they even made some objects out of metal. But there are few extant examples of any metal devices. You've all seen hieroglyphics. Hieroglyphics was used by the ancient Egyptians to write with. It's based on pictograms. However, for centuries, no one knew how to read it. Then, in 1799, some French soldiers in Napoleon's army discovered the Rosetta Stone in Egypt. It was part of a wall in an old fort in the town of Rosetta. It was originally located in an ancient temple, but it was later moved to the fort. The Rosetta Stone had some writing on it. The writing was in 3 languages. One was ancient Greek, one was Demotic, that's an ancient Egyptian language, and the other was hieroglyphics. All 3 languages contained the same information. It was a decree issued by some priest in 196 BC. It was about the new pharaoh of Egypt, Ptolemy V. The priest declared that Ptolemy had been chosen to rule, and they said that they would honor Ptolemy with a feast each year. The text on the Rosetta Stone became the key to understanding ancient Egyptian hieroglyphics. Scholars started to compare the 3 writings. They understood the ancient Greek very well. The second writing, Demotic, was less well known, but some scholars came to understand it. Eventually, after much work, scholars started to decipher what the picture symbols and hieroglyphics meant. 2 men were involved in most of the important translation work. The first was Thomas Young, an Englishman. In 1814, he made the first major discovery. He realized that the 3 texts contained the same information. He found about 80 words in the Demotic and hieroglyphic texts that were similar to words in ancient Greek. For example, the name Ptolemy was Greek. It appears several times in all 3 texts. Young was able to figure out which symbols in Demotic and hieroglyphics represented the name Ptolemy. The other scholar was a Frenchman. His name was Jean-François Champollion. In 1822, he produced an alphabet for hieroglyphics based on the Rosetta Stone inscriptions. Later, he made a grammar and a dictionary for hieroglyphics.
We all know that the capital of the United States is Washington, D.C. However, when America first became a country, Washington didn't even exist. Back then, Philadelphia was the logical choice as the new country's capital.
Why Philadelphia? Why not Boston, New York, or even Charleston?
For several reasons. First, Philadelphia had a roughly central location in the U.S. at that time. Also, it had been a focal point of the American Revolution. The Continental Congress had met there before the war, and several major events took place there. So, why is Washington the capital and not Philadelphia? Mostly because of a riot in Philadelphia in 1783. Congress was meeting there when some soldiers disrupted them. The soldiers demanded payment for their service during the war, but Congress had no money. It asked the government of Pennsylvania to protect it, but the government refused. Congress promptly left Philadelphia, so that ruled out Philadelphia. Congress realized it couldn't rely on the states to defend it. Thus, the members of Congress decided to create an entirely new area called the District of Columbia. Several states competed for the right to host the district, but ultimately, Congress decided on a stretch of land between Virginia and Maryland. Like Philadelphia, it was near the geographical center of the country. The necessary land was given to the federal government. Construction on the new capital then began, and that's how Washington, D.C. became our capital. Let's look at its design now.